Alright, hello everyone. Welcome to our lesson, and the first one in the new year here, about perception. This is the second part of that. We have our objectives and standards here. So objectives, how we analyze how we perceive and explain other means of perception. And take a moment there to read over the standards. And our desired result for today is how do other forms of perception impact our views? We have some vocabulary here. Motion parallax is apparent movement of stationary objects relative to another that occurs when the observer changes position. Again, we'll talk a little bit more about that. Constancy is the tendency to perceive certain objects in the same way, regardless of changing angle, distance, or lighting. An illusion, a perception that misrepresents physical stimuli. And extrasensory perception, or ESP, is the ability to gain information by some means other than the ordinary senses. So the perception of depth, the ability to recognize distances and three-dimensionality is known as depth perception. This typically develops during infancy, and if you will remember, when we talked about lifespan development, for those of you who were here in the class at the time, where they did the visual cliff experiment, where children were placed over a board or a plank where glass was, and they would kind of come to the edge, and as they viewed the edge, many of them would just kind of cross it without really seeing that there was an edge over top of it. Or as they got older, children would realize that that maybe it was a little dangerous and maybe they shouldn't approach the cliff. If you don't know anything about that, you're free to look that up for yourself if you'd like. Again, that's the visual cliff experiment, and highlight it there for you. We also use monocular depth cues to perceive depth and distance. These are cues that can be used with a single eye and include at least a half a dozen cues. Examples include things that are like bigger is nearer, relative height, interposition, and the view that lighter images are closer than darker shadows. So we see something that might be brighter to us, we perceive that as being a closer object than something that's darker, where we might say, oh, that's further away. Motion parallax has to do with the apparent movement of objects that occurs when you move your head from side to side or walk around. It allows us to determine where objects are close. Which objects are closer and which are far or farther. I guess I should fix that here. It should say farther. Fix that real quick for you. Farther. There we go. Excuse my shaky marker handwriting there. Farther. Now, some of these include, one of these is linear perspective, and that's the first one up here that you'll see. The linear perspective is the blue line there. So it involves parallel lines that converge eventually when stretched over a long distance. So here it looks like we have a railroad track, and you'll see that as it looks like we have our horizontal line, which is the horizon in red here, eventually the railroad tracks seem to meet up with the horizon. Now again, we know that these railroad tracks go on and on and on for however far they may go. They don't just meet the sky and disappear, but we call that the vanishing point. But again, this is known as linear perspective because as we look at this and it gets further and further away from us, we can, understand that the railroad tracks are still going on even though we can't see them. Another example is relative motion. That's the second picture down here. I put a bike going in motion this way, and then it's kind of hard to see, but there's another green arrow here pushing another way. So what this means is, so think about when you're riding in a car and the objects outside the window seem to move the opposite direction, but the landscape does not. So when you're sitting in a car, or driving in a car, or whatever, and you're riding somewhere, or even riding a bike or in a train or something like that, and as you move forward, if you look out the window or move your head, the trees will go past you on the opposite side. Now you know the trees are not physically moving past you, you're riding in a certain direction, but again, this feels that way because this is relative motion. But we know that when we look at the landscape, we know that the trees may not be moving, but other objects may be. The cues of binocular depth. These depend on the existence or movement of both eyes. So this image is a little tricky to understand here, but we have both eyes here. So imagine this is your left eyeball, your right eyeball, and we're looking at maybe our fingertip in a tree in the same, if we hold our fingertip up to our eye, or our eyes, if you do that right now, you can hold your fingertip up to your eye, And it looks as if your eyes, you can focus on your fingerprint and feel, it looks like your fingertip is bigger than maybe, I don't know, something in front of you. Maybe it's your TV, maybe it's a lamp. But again, in reality, your fingertip is not bigger than that. But because the object is closer to you, you feel that your fingertip is bigger. So that's what this picture is showing here, is that, if we hold our fingertip out in front of us in front of a tree, like I'm doing right now, I can look out the window and hold my fingertip up to a tree, and it looks like my fingertip is probably bigger than that tree. But in reality, I know that it's not bigger than the tree. I know that my finger is smaller, but because of how my binocular depth is, it identifies the closest object, and it looks at the nearest object, so that makes it feel as if that object is bigger. So convergence and retinal disparity. The convergence is how our eyes turn inward to focus on a certain point there. You can see that here. See how the eyes are kind of, we don't physically see it, but the eyes are kind of turning inward to focus on that object, or also on the tree here. And then retinal disparity is what I was just describing, is when our fingertip, we look at our fingertip and say, oh, that's pretty big, that's bigger than, my TV. But in reality, it's not. We know that it's not, but we can feel that way because of our depth perception and our binocular depth here, that our finger is bigger. Perception and constancy. Once we perceive an object in our environment a certain way, we tend to see that item the same way regardless of changing conditions. For example, when it snows, we know that snow typically tends to be white. Whether it be a sunny day, if it's snowing and it's a sunny day outside, the snow is white, or if it's a cloudy day, we know that the snow is white. It doesn't tend to change. We understand snow is typically white. So it doesn't change with the changing conditions, whether it be sunny in the morning and then cloudy in the afternoon, we know the snow is still white. Despite changing conditions, like we just said, we are able to perceive objects the same by a process that is known as constancy. There's an example here too, that size constancy is maintained as we perceive each yacht to be the same size, despite differences in the size of each boat's image cast onto the retina. So even though it looks like this boat may be bigger than these other two boats, we know and understand that all three of these boats are the same size. It just has to do with how far away they are from each other. So that has to do with size constancy. So we're not just saying, oh, well, because that boat's farther away, that must mean it's a smaller sailboat. Well, probably not. They're probably the same size sailboats. It's just that with the other two being further away, they look smaller. Another example to think about is, imagine if your friend stood at one side of a room and walked towards you. Their size may change. They may get, as they get close to you, they may get taller, but their overall appearance isn't going to change, right? Their hair is not going to change, their clothing's not going to change, their face isn't going to change, and we know that. Again, this is constancy. We know that as our friend walks towards us, yeah, they might get bigger because they're walking towards us in size, but their overall appearance is not going to change. What they're wearing, what their face looks like, their hairstyle, whatever the case may be. Viewing illusions. There are incorrect perceptions, and these are known as illusions. You've probably seen these many times or sometimes in your life. Now, sometimes they are confusing, but they can be useful in teaching us how our sensory and perception systems work. When perceptual cues are distorted in a way that our brains cannot interpret size, depth, and shape, this is what creates an illusion. Let me give you some examples here. You may have seen these before, I'm not quite sure, but this one here. For example, take a moment here and look at this. Let's look at this first one here that I'm highlighting in yellow, and tell me what you see. Or, well, you don't have to tell me what you see, but think about what you see. What's the first thing that sticks out to you? The first thing that I see, I'm going to highlight this in purple, is a vase or a vase or something like that, maybe you put flowers in or whatever the case may be, but I see a vase or a vase, whatever you want to say. Now, if you look again, I'm going to highlight this in green, or maybe you see two different faces. We have a nose here, we have what looks like a mouth, and then the chin and the neck. And again, here's the second face. So again, this is just an example of illusion. This is a very famous illusion. So again, it depends on how you look at it. Same thing here. Just these pictures are just reversed. Do you see a, maybe a young queen or a young monarch, a younger beautiful lady with a crown on her head? Or if we flip the image, I'm going to do this and just kind of try and draw some arrows to show you. If we flip the image, it could be an older lady who looks, maybe she's upset about something or, not feeling well. So again, another illusion that, that you can kind of see. And again, this changes our perception because our brain goes, huh, wait, what are you doing there? It changes our perceptual cues about size and shape and depth cues, and it makes us wonder and think about things. The use of extrasensory perception, or ESP. Humans are fascinated by what we cannot see or things that cannot be easily explained. Some examples of this could be flying saucers or UFOs. And also another thing is extrasensory perception. Many people believe that extrasensory perceptions are real because they have had some type of personal experience with them. I'm going to give you an example of it on the next slide. Extrasensory perceptions involve receiving information about the world through channels other than our normal senses, such as sight, touch, smell. And extrasensory perception remains a highly debated topic today. There have been scientists who have investigated ESP since the 1990s. A very famous ESP parapsychologist who studied these many, many years ago was Joseph Banks Rhine, better known as J.B. Rhine. He lived from 1895 to 1980. He was well known for his study of this. And like I said, scientists still study the possible existence or use of these today. Many of them have said they've not been able to find any highly supportive evidence of ESP, but these studies are still ongoing. So let me give you some examples of them. There's 4 types of ESP. Clairvoyance is the first one there, which is perceiving objects or information without sensory information. Number 2, telepathy. Maybe you've heard this before. This could involve reading someone's mind. Number 3, psychokinesis is moving objects purely through mental effort, so moving a pencil across the room with your mind or something like that. And then number 4 would be precognition, which would be the ability to foretell events before they happen. So maybe or maybe somebody says, oh, this is like a fortune teller almost saying you're going to get sick in 2 weeks. They're foretelling what's going to happen to you. All right, so please be kind to try your best on the questions that follow. Think about the desired result question again and be sure to respond to that, and the anticipatory set question. And if you have any questions, let me know, and I'll talk to you soon.